What a beautiful venue we have today. Did you have time to look a little bit? It's going to be a completely different topic, so we need to disconnect from what we had before. But how you feel if I will ask you now to help me to renovate a little bit this place? Change the painting, change some of the curtains, do some little job like this. I think we will probably start to feel a little bit unsecure what will be the final result of it. Because we miss the final real expert that can make this place become even more beautiful. As a scientist, as an engineer, when I start a new project, when I embrace a new challenge, this is what I feel. I think that I have a lot of knowledge. I think that I will be able to answer a few questions, but perhaps I still miss the final experts that make my field of research to become even bigger, to be applied. This is what is about macroalgae, seaweed. Probably most of you have already heard about this. We spend a lot of money as well and research and year to try to get this field of research farther up, farther up, farther up. But we're still not really there yet. And I hope today, here in Brussels, in this audience, to find the final expertise that will help me to make things step forward. I will tell you a story. This is a picture of a farm, and what the farmer does is to cultivate vegetables and grow vegetables in his land. But to do that, he needs to provide his land with some additional nutrient, with substances that then can be used by the plant to grow. Now, part of this this nutrient will be used by the plants, but as seasonal variation change, part of this nutrient will remain and will escape this land and will finally reach river and lakes to finally accumulate in the final reception, which is larger sea or a larger lake or a sea. Here is going to be basically Christmas for fishes, local fauna and flora, where this nutrient will help to really grow the algae, the fish, farther down. Until one point when they will use all the nutrients available, and there will be such a bloom of production which the sunlight will not be able to reach the water anymore, and everyone will die. From a very nice situation, we will reach a point where we have a sort of toxic system. This story is called Electrification, and it is quite very well known all around Europe. How to solve these things? Well, the European Commission has been very proactive on this, embracing new legislation, production of research, new technology that can prevent and limit the amount of nutrient that escape the land or other sources to reach the final water. So, if in the past we had a lot of nutrients reaching the final water, now today we are in a situation where we have more sustainable use of nutrients. However, we realize that we are not doing enough, and we want to go farther down, reducing even more the amount of nutrients that are in our aquatic environment. Now, if we look back to our story and we consider the impact of the European Commission and the legislation and all the work that we have done so far, where should we act? Shall we implement even further legislation? Shall we implement new technology? Is where is my research come into? I would like to act in this point. I would like to act where the nutrients are not in the water anymore, but are actually in the algae, in the fish, in the very happy environment where the nutrient being transformed and used. So what if we use the algae, this biomass, to recover the nutrient? This is the big question. And this is what I've done. I've been around for a few years to collect different kinds of algae and try to understand what is actually the amount of nutrients that we have in this biomass. That was the first question. If we take 10,000 tons of algae, we have about 35 tons of nutrient. That's not a small number. Today, with our technology, with our community wastewater treatment plant and so on, to remove 35 tons of nutrient, we spent 1.5 million euro. That's a big number. The algae do this for free. They just grow. So the first question was answered. The algae pick up a lot of nutrient, and they're quite cheap to do it. But if we have 10,000 tons of algae, that's the question, is what we're going to do with this biomass. It's not something that is small. Well, again, luckily enough, this biomass, consider that we don't want to eat sushi every day for 10,000 tons, can provide energy in terms of biogas, in terms of biomethane. And that is a quite well-established technology that we have. We can use algae together with other sort of waste. From 10,000, we are around 300,000 cubic meter of methane. That's enough to power 3 local buses in Stockholm for 1 year. That's not too bad. So, where is the problem? We have the biomass, we have the nutrients, we know what to do with this biomass. But we still have a problem. And when we come to costs and benefits, that's where we stuck. Again, our 10,000 ton of algae today, that's the figure. We spend much more to collect this amount of algae than what we can gain by produce energy and sell it. And here is where I stop. I answered my question. I was looking at nutrients. I was looking how to make this algae feasible and valuable for energy production. Now we are not talking about science anymore. We are talking about business. We are talking about economy. And here is where I need Brussels. From the previous picture, we were missing something. We are talking about algae, we are talking about energy. But what about environmental benefits that algae does picking up nutrient? They don't spend 1.5 million, which we are spending to do it in a different way. So if we take this into account, and we are in a situation where, well, we consider the environmental benefits, we still have our 10,000 tons of algae, the situation will change completely. Because we can use that 1.5 million to cover somehow, as a social benefit, the cost to bring up those algae. And the remaining parts, that will be to support business, to support economy, to support company to grow. If we go back to our story, we said we have the European Union already doing some important work, and that will be still there. But then, if we take into account the use of these environmental benefits for the use of algae, what will happen? We can have actually recovery of nutrients we can use back to the farmer. We can use this biomass to produce new energy, powering bus and so on. And we finally have an environment when the fish can still grow and we still have algae, and we actually solve the problem. Now, I don't call this eutrophication anymore. I call this green economy. I call this sustainable development. I call this sustainable energy. But again, the science answers this question. We answer what to do. We answer how to do it. Perhaps we still have some question to understand how we can do it better. But the economy will take years to come without the help of you. So I made my race. Now it's your turn. Thanks for listening.
Thank you, Francesco. Any questions in the audience for Francesco? Anyone want to kick us off? Anyone from Brussels with a bit of money to help? Got anything to add here? Yeah, oh, we've got one from Ari and Marie at the front here. Wait for your microphone.
Have you been in touch with the EU Commission, with the services of the EU Commission in order to present your project?
We have some ongoing similar projects, and still there is, especially in the Baltic area, quite a big movement which is trying to consider sort of changes legislation what we are talking, because the current legislation take into account the fact that we don't want to have the nutrients reaching the sea. That's what we are doing. But the concept now is to take the nutrients that are already in the sea and take them out of it. So the process is a little bit long, of course, but there is some sign of development in this sense as well. And definitely, especially in the Baltic region, local community are doing an important work to try to push this further up.
Okay. Any other questions? Yep, the lady in red at the front.
Hi, I would like to ask you, are there differences between the algae of the Baltic and the Mediterranean, and whether this has any impact on your work? Thank you.
Yes, different area will impact in different species of algae, sort of different species of plants that you can find in different environments. In terms of nutrient uptake, that probably it's not going to be much difference. In terms of the energy that we can gain from different algae, that's my impact. Especially because different algae will have different structures. So while we can identify some species that can be easily converted to biogas without the use of any pretreatments, for instance, some other species might need some additional pretreatment to make sure that we can gain all the potential energy.
Okay. Time for one last quick question. Yep, we got one here at the front.
Hi, Matthew Wade from Newcastle University. I guess you're co-digesting your seaweed. What typically do you co-digest with?
Yes, that's correct. It's a biomass that cannot convert in itself, only in terms of what we use normally with food waste or wastewater sludge. And in our research, we were using wastewater sludge. Currently, we have a project going on in Norway with Scandinavian Biogas, another company, funded partially also through some the LIFE projects. And that, on the long term, there is the idea to co-digest seaweed together with sludge from pulp and paper mill wastewater treatment. So that's another option, but it's always a co-digestion.
Okay. Francesco, thank you very much.